Good morning, dear students. Welcome to my channel, Guru. My name is Mahesh Kumar, Senior IIT Maths Lecturer. Today, we are going to see the next level of partial fraction, which is rule number 3. In the previous classes, we have done rule number 1 as well as rule number 2. Presently, we are going to learn rule number 3. Right? So, first let us see what is rule number 3 in partial fraction. The rule 3 is to obtain the partial fractions of f of x by g of x if g of x contains non-repeated irreducible factors. In one of the method we have seen the first method, rule number 1, some problems belongs to reducible. Here purely g of x is non-repeated irreducible factor. In such case, what to do? So once again, the procedure is we need to verify f of x by g of x must be a proper fraction, and for each non-repeated quadratic factor, rule number 1 and rule number 2, we have discussed about linear factors. Linear factor is nothing but whose degree is 1, and presently we are dealing with quadratic factor whose degree is 2, and this cannot be irreducible because some quadratic factors are reducible. When it is reducible, comes under rule number 1, but when it is irreducible, then for each of the form we need to consider the partial fraction of the form ax plus b by ax square plus bx plus c, where we need to find these values a and b. So this is a procedure. So always when we apply after doing rule 1 helps us to solve the problems of rule 2, and rule 1, rule 2 helps us to solve the problems of rule 3, because even along with this irreducible quadratic factor, there might be a quadratic linear factor or a repeated linear factors also. Let us see this with an example. So for suppose is asking to resolve 2x square plus 3x plus 4 by x minus 1 into x square plus 2 into partial fraction. Right? The question is to find or resolve this into partial fractions. So first let us check. Let us see what is that. Degree is 2, denominator 1 plus 2 is 3. So numerator degree is 2 and denominator degree is 3. So this is less than this. Hence the given question is a proper fraction. So whatever the given question is there, that is 2x square plus 3x plus 4 by x minus 1 into x square plus 2 is a proper fraction. So first we identified that this is a proper fraction. Once after identifying proper fraction, let us consider the question 2x square plus 3x plus 4 by x minus 1 into x square plus 2 is. First look at the first one. What is this x minus 1? X minus 1 is a linear factor, right? So for linear factor comes under rule number 1. So in rule number 1 what we have discussed, for each linear factor we need to write a partial fraction of the form a by ax plus b. So a by x minus 1. Then the second one, x square plus 2. What is x square plus 2? X square plus 2 is a quadratic factor which is irreducible, right? So this is a quadratic factor and which is irreducible. So for irreducible, what we need to write? The form ax plus b by ax square plus bx plus c. So for this x square plus 2, because this is a irreducible quadratic factor, we need to write partial fraction of the form ax plus b. But already we have taken a, go for the next letter, bx plus c by the quadratic factor, which is x square plus 2. So this is what the required equation. Here in this a, b, c values has to be determined. Now let us take the LCM for that. So 2x square plus 3x plus 4 by x minus 1 into x square plus 2. If we take the LCM here, x square plus 2 cross multiplication a into x square plus 2 bx plus c into x minus 1. So both sides, the denominator term gets cancels, right? So remaining 2x square plus 3x plus 4 is equals to a into x square plus 2 bx plus c into x minus 1, right? Once after, again here we have a linear factor x minus 1. So by replacing x equal to 1, we are going to get one of the value of it. So let us replace x value as 1. So put x is equals to 1 in equation number 2. So what happens? 2 into 1 square plus 3 into 1 plus 4, which is equals to a into 1 square plus 2 plus b into 1 plus c 1 minus 1. So 2 square, 2 into 1 square is 2, 3 ones are 3 plus 4, 2 plus 3 is 5, 5 plus 4 is 9 is equals to 1 square is 1 plus 2 is 3, 3a. And here you can observe that here 1 minus 1 is 0. So the entire term becomes 0. Nothing but 3a is equals to 9 and a can be written as 9 by 3. Otherwise the value of a is 3. Now we got out of a, b, c one value a. Next we need to find one more value, that is b as well as c. To find two more values, there is no other linear factor to substitute. Then what to do? In this case, already in rule number 2 we have discussed, whenever there is no possibility to substitute, simply go for the simplification of the second equation. Let us simplify the entire equation. So simplifying equation number 2. If you simplify equation number 2, what happens? Left side is 2x square plus 3x plus 4 is equals to a into, this is x square plus 2. So try to write a into something, b into something, c into something. Here b, this x into x minus 1. X into x is x square minus x into 1 is x. Then this c into the entire term, which is c into x minus 1. So we have expanded the second equation. After expanding second equation, let us compare the terms on both sides. So let us take the like terms. So compare. So coefficient of something x square. So how many x square terms are there? 1 and 2. 1 into a is a, 1 into b is b, and left side x square quotient is 2. So let us write 2. Then take coefficient of x. Before that, a plus b equal to 2. What is a value got here? 3. Let us replace here. If you replace a value as 3, 3 plus b is equals to 2. Nothing but b is equals to 2 minus 3. Nothing but minus 1. So we got b value is minus 1. Similarly, go for coefficient of x. So how many terms are there? X terms 1 and 2. B into minus 1 is minus b. C into 1 is c. Right side x coefficient is 3 is equals to 3. Here minus b plus c equal to 3. Already you got b value. That is minus 1. Replace here. Minus of minus 1 plus c is equals to 3. So c is equals to this minus of minus becomes plus. Plus 1 if we send right side, it get minus 1 which is equals to 2. So the value of c is 2. Hence we got a value, b value, c value. So finally substitute these all values in the first equation. That is from first equation what we can write? 2x square plus 3x plus 4 by x minus 1 into x square plus 2 is a by x minus 1. What is a? 3. 3 by x minus 1 plus bx. What is b value? Minus 1. So minus 1 into x plus c. What is c value? 2 by x square plus 2. Otherwise same can be written as 3 by x minus 1 plus first write 2 minus 1 into x minus x by x square plus 2. So this is the solution of this problem, right? Here we are doing solving problems of rule 3. What is rule 3 says? If f of x by g of x and g of x contains non-repeated irreducible factors. When it contains non-repeated irreducible factors, what we need to take for each quadratic factor? We need to take a partial fraction of the form ax square plus bx plus c. So in the given question we have verified that x minus 1 is a linear factor. That's why we took a by x minus 1. Whereas x square plus 2 is a quadratic irreducible factor. That's why we have taken bx plus c by x square plus 2. Then after LCM cross multiplication, then there is a possibility to replace x value 1. We have replaced so that we got a value. Then after there is no chances to replace, so just simply we simplified second equation, then compared the quotients on both sides by taking x square quotient and x quotient. We got the remaining two values and we substituted all these values in the first equation to get the required answer. So this is one example, and let us go for one more example to get a clarity on this, right? So let us see one more example. Right? Let us go for next example. The example is 2x square plus 1 by x cube minus 1. So resolve 2x square plus 1 by x cube minus 1 into partial fractions. So this is a question, right? Now you can see here the degree of numerator is 2, degree of numerator is 3. So numerator is less than the denominator, hence it is a proper fraction. So given 2x square plus 1 by x cube minus 1 is a proper fraction. So first condition is verified. Then till now we have discussed three rules. Rule number 1 says linear factor. Rule number 2 says repeated linear factor. Rule number 3 says quadratic factor. But if you observe g of x denominator, here it is a cubic factor. So cubic factor we didn't discuss. Then how to do? Just simply try to make it as a product of two factors if possible. Yes, let us see here. X cube minus 1. What 1 can written as? 1 can written as 1 cube. So which is of the form a cube minus b cube. What is a cube minus b cube? A minus b into a square plus ab plus b square. So what you can write this? You can write as x minus 1 into x square plus x plus 1. Yes, the given question can be written as product of two factors. So the given question x cube minus 1 is a reducible, right? So because it is reducible, we can write this x cube minus 1 as product of two factors. Let us take that. So let 2x square plus 1 by, what is x cube minus 1? Which is x minus 1 into x square plus x plus 1. So we have replaced x cube minus 1 with this. Once again, here x minus 1 is what? Linear factor. For linear factor, what we write? A by x minus 1 plus this x square plus x plus 1 is a quadratic factor. For quadratic factor, what we write? Bx plus c by x square plus x plus 1. So this is what the required equation, right? Now same thing, go for the LCM. So 2x square plus 1 by x minus 1 into x square plus x plus 1, which is same as, if you go for the LCM, x minus 1 into x square plus x plus 1, cross multiplication, a into x square plus x plus 1 plus bx plus c into x minus 1. So this gets cancels, remaining 2x square plus 1, which is a into x square plus x plus 1 bx plus c into x minus 1. Let us take this as equation number 2. Now we have only one factor. What is that? X minus 1. So when we take x minus 1 is 0, x equals to 1. So let us take x value 1 in equation number 2. So what do you get? 2 into 1 square plus 1 is equals to a into 1 square plus 1 plus 1 plus b into 1 plus c into 1 minus 1. So 2 into 1 square is 2 plus 1 is 3 is equals to a into 1 plus 1 plus 1 is 3. 3a, and you can see here this 1 minus 1 gets cancelled, the entire term becomes 0, so this is nothing but 0. So 3a equal to 3, nothing but a can be written as 1, as 3 ones are 3 ones are gets cancelled. Now we have a value and there are no other possibilities to substitute. Then what to do? Just take the simplification of second equation, right? So simplifying equation number 2. What is second equation? 2x square plus 1 is equals to a into x square plus x plus 1. Then x into this. So b into x square minus x plus c into this. C into x minus 1. We have written a into something, b into something and c into something. Now go for the comparison. Let us take coefficient of x square. So this is one term and this is another term. A into x square a, b into x square b, and left side we have 2. So a plus b equals to 2. But what is a value? 1. If you replace here, 1 plus b is equals to 2. B is equals to 2 minus 1. Nothing but 1. We got b value. Then go for coefficient of x. What is coefficient of x? Here one term is there and here second term is there. Here third term is there. A into 1 is a. B into minus 1 is minus b. C into 1 is c. Left side there is no x term. So 0. What is a? A value is 1. Minus what is b value? 1. Plus c equal to 0. This gets cancelled. C equal to 0. So that we got all the three values. Now replace these three values in the first equation. That is, from first equation, what are you going to write the given question? 2x square plus 1 by x cube minus 1 is a by x minus 1. What is a? 1. 1 by x minus 1 plus b. What is b? B value is 1. So 1 into x plus c is 0 by x square plus x plus 1. Otherwise you can write 1 by x minus 1 plus x by x square plus x plus 1. So this is the solution for the given answer. I think you got clarity on this even rule number 3. So we have discussed totally 3 rules. First rule is for linear factor, second rule is repeated linear factor, third rule is quadratic factor, and in the next class we are going to see repeated quadratic factor. When repeated quadratic factor is there, how to solve the problem we are going to see as rule number 4. Thank you very much.